We once thought we understood the scale of the universe. Back in 2004, the Hubble Space Telescope's ultra-deep field stunned astronomers by revealing nearly 10,000 galaxies in what had appeared to be an empty patch of sky. That single image shaped our estimate that the cosmos might contain as many as 2 trillion galaxies. But even this astonishing glimpse was only a fraction of reality. Hubble could see only invisible and ultraviolet light, missing what lay hidden behind cosmic dust and the red-shifted glow of ancient galaxies. Now, the James Webb Space Telescope has shattered those limits. In a single 250-hour observation campaign, Webb's Cosmos Webb mosaic uncovered not 10,000, but nearly 780,000 galaxies, all packed into a region no larger than 3 full moons in the night sky. These galaxies reach back more than 13.5 billion years, to a time when the first structures in the universe were forming. The discovery doesn't just expand our sense of scale, it rewrites our understanding of cosmic evolution itself. How could such vast structures and mature galaxies exist so early, in regions that once seemed completely empty? It all began when Hubble first peered deep into the constellation Fornax for 11 straight days, producing the ultra-deep field, a now iconic snapshot that revealed a cosmos teeming with galaxies. What looked like darkness turned out to be filled with entire universes of stars, each dot of light a galaxy containing billions of suns. That single image, no bigger than a grain of sand held at arm's length, became the foundation for our estimates of a 2 trillion galaxy universe. But Hubble's view, for all its depth, had a limit. Its 2.4-meter mirror could not see the faint infrared light emitted by the most distant galaxies. Their ancient glow, stretched by the expansion of space itself, slipped beyond what Hubble could ever detect. James Webb, however, was built precisely for that. With a mirror 6.5 meters wide, more than 6 times Hubble's light-gathering power, and eyes tuned entirely to infrared wavelengths, Webb can pierce through cosmic dust and detect light from the earliest galaxies ever formed. If Hubble's vision was like peering through a keyhole, Webb's is like stepping back to see an entire cosmic mural. Imagine the Hubble ultra-deep field as a single sheet of paper. At the same depth, Webb's Cosmos Webb would fill a mural 13 feet tall and 13 feet wide. Over 250 hours of observing time were devoted to this project, scanning a patch of sky 3 times the size of the full moon and stitching thousands of exposures into a seamless mosaic. The largest and deepest panoramic map of the universe ever made. Within that single image, astronomers identified nearly 780,000 galaxies, each a city of stars, some shining from just 400 million years after the Big Bang. The map is both wide enough to reveal the cosmic web of filaments, clusters and voids that shape the universe, and deep enough to capture its faintest, oldest light. It's not just a bigger picture, it's a new kind of cosmic atlas, one that challenges everything we thought we knew about the size, age, and complexity of the universe itself. For the first time in history, astronomers can now observe not just isolated galaxies, but the grand tapestry of the cosmos itself, the full sweep of structure stretching across billions of years, all within a single, continuous frame. Thanks to the James Webb Space Telescope's infrared vision and unprecedented reach, the universe has opened a new window on itself, revealing both its unimaginable scale and the hidden depths of its evolution within the vast Cosmos Webb mosaic. In the nearby universe, this map captures a realm of fully mature galaxies, elegant spirals, smooth ellipticals, and chaotic mergers locked in gravitational dance. Astronomers can now trace how these systems weave together into colossal filaments and galaxy clusters, forming the immense scaffolding known as the cosmic web, the very backbone of the universe. Yet, among these countless shapes and collisions, one discovery stands apart, a system now known as the Infinity Galaxy. At a redshift of 1.14, this extraordinary object reveals itself as a glowing figure-8 silhouette. Two disk galaxies colliding almost head-on. Each retains a compact red core, surrounded by luminous rings of stars and gas, their orbits twisted by the power of their cosmic encounter. The collision, which occurred around 50 million years ago, is more than a spectacle. It has exposed conditions never seen so clearly before. Between the two galactic centers lies a massive cloud of ionized hydrogen, glowing with the energy of something extraordinary. Deep observations from JWST and NASA's Chandra X-ray Observatory have uncovered the signature of a supermassive black hole, not in either galaxy's core, but suspended in the void between them, embedded in the turbulent gas. Its motion perfectly matches the surrounding material to within 50 kilometers per second. This off-center black hole, about 1 million times the mass of the Sun, is joined by two more, each galaxy's original core harboring its own active black hole, confirmed by their broad hydrogen emission lines. 3 active black holes, 2 anchored in their galaxies, 1 adrift between them. The evidence suggests the intergalactic one did not come from a merger or ejection, but formed directly in place, collapsing from dense, shocked gas funneled into the center of the collision. Captured mid-formation by Webb's infrared eyes, it offers a rare glimpse into how supermassive black holes might seed themselves in the chaos of galaxy assembly. The Infinity Galaxy is more than a curiosity. It's a revelation. Its figure-8 form, with a black hole growing in the emptiness between colliding worlds, hints that the universe's most powerful engines may sometimes ignite not at the hearts of galaxies, but in the turbulent regions where galaxies themselves collide. It's a discovery only possible through Webb's panoramic view, a cosmic event so complex and fleeting that it would have remained invisible without the vast, deep field of the Cosmos Webb survey. From here, the journey continues deeper into the mosaic, back to an era astronomers call cosmic noon, roughly 10 billion years ago, when the universe was at its most prolific in forging new stars. The galaxies seen in this epoch are astonishing, vibrant, dynamic, and yet surprisingly mature. Webb's infrared vision reveals galaxies that appear far too organized, far too calm for such an early time in history. Even more puzzling, some of these galaxies, the so-called quenched systems, have already stopped forming stars entirely, despite existing in a period when the cosmos should have been ablaze with stellar birth. These dormant giants, with masses rivaling today's largest ellipticals, sit quietly amid a universe that theory once predicted would be wild and chaotic. But Webb's discoveries keep defying expectation. Among them are spiral galaxies, with beautifully defined arms and even central bars, signatures of stability and maturity, appearing just 2 to 3 billion years after the Big Bang. In cosmic terms, that's impossibly early. Yet here they are, massive, symmetrical, and serene, their spiral arms winding gracefully around dense cores. The James Webb Space Telescope has revealed not only a deeper universe, but a more advanced one, a cosmos that grew up faster, structured itself earlier, and hides far more complexity than anyone ever imagined. The data now reveals something astonishing. Disks capable of supporting spiral arms and stable structures were far more common, far earlier than anyone ever thought possible. This early order isn't just a matter of beauty. It's a fundamental shift in cosmic history. The existence of stable, well-formed disks and quenched giant galaxies during cosmic noon means that the forces shaping galaxies and shutting down star formation must have acted with incredible speed. The timeline of complexity in the universe is shrinking. Each of these galaxies becomes a vital clue, a piece of evidence that forces astronomers to rethink how fast the cosmos can evolve, how quickly it can transform from chaos into structure, from turbulence into order. The universe's growth, once thought to be a slow unfolding, now appears as an explosive acceleration. Webb's map isn't just more detailed. It's rewriting the rules of how galaxies grow up. At the very edge of what the James Webb Space Telescope can see, we now find the farthest confirmed galaxies ever detected. The record belongs to JADES-GS-z14, whose light began its journey just 290 million years after the Big Bang. Close behind, MAMZ-z14 shines from only 280 million years after the beginning of time itself. Both have been spectroscopically confirmed, their distances precisely measured by sharp Lyman breaks captured in Webb's NIR spec data. But the revelations go even deeper. Using the Atacama Large Millimeter Array, astronomers have detected oxygen within JADES-GS-z14, a stunning discovery that means heavy elements already existed less than 300 million years after the Big Bang. That's evidence that at least one full generation of stars had already lived, burned, and died, enriching these young galaxies with metals forged in their cores. Each of these systems shines with the light of hundreds of millions of suns, compressed into compact, furious starbursts. Their existence, and their chemical fingerprints, suggest that galaxy formation and stellar evolution began at a breathtaking pace. Within just the first 300 million years, the universe was already busy building complexity, forming stars, and creating elements that would one day make planets and life possible. The flood of discoveries pouring in from Webb's vast new map is forcing astronomers to rethink the entire story of cosmic dawn. We now know that galaxies and black holes emerged earlier and grew faster than any previous model allowed. Even these distant record holders, JADES-GS-z14 and MAMZ-z14, contain heavy elements, proof that cycles of star birth, death, and enrichment began almost immediately after the universe was born. What once seemed like a slow, billion-year climb toward complexity now looks like a cosmic sprint. The old narrative, a gradual evolution from simplicity to structure, has been replaced by one of rapid transformation. The processes of reionization, the growth of massive halos, and the birth of supermassive black holes all appear to have accelerated beyond expectation. The universe's earliest chapters are being rewritten in real time, and each new discovery from Webb raises deeper questions about how it all began. In just 250 hours, the James Webb Space Telescope's Cosmos Webb survey mapped nearly 780,000 galaxies, almost 80 times more than Hubble's ultra-deep field revealed in 2004. This sweeping infrared panorama captures galaxies and cosmic structures stretching back 13.5 billion years, including record breakers like JADES-GS-z14 and MAMZ-z14, both seen less than 300 million years after the Big Bang. Webb's data show that mature spiral galaxies, colossal mergers, and heavy elements all appeared long before theory predicted. Yet the mysteries remain. How did galaxies and black holes grow so fast? What hidden roles did dark matter, turbulence, and feedback processes play in shaping them? Every observation brings us closer to understanding, and yet also reminds us how much we still don't know. Because even after mapping nearly 1 million galaxies, this survey covers only a tiny patch of sky, a fraction of what's out there. It's a humbling reminder that the universe is vastly larger, older, and more intricate than we ever imagined, and that Webb has only just begun to show us what lies beyond.